Assalamu alaikum. Hello everyone. Today I am going to discuss with you some problems from integral calculus. Before going to the problem, first I will give you uh, some idea about the basics of integral calculus. What is integral calculus actually? Integral calculus is a branch of mathematics focused on integrals and their properties. It deals with finding the accumulation of quantities and the area under curves, essentially providing a way to reverse differentiation. There are two main types of integrals in integral calculus: definite integral, indefinite integral. Definite integral, it represents the area under a curve within a specific interval. It noted as this. Here it will give a numerical value, okay. And indefinite integral, it represents a family of functions whose derivative is the original function, noted as the integration of f of x dx is equal to f of x plus c. The result is a general antiderivative where c is constant of integration, okay. Now fundamental theorem of calculus, it connects differentiation and integration, stating that if f is an antiderivative of f, then integration of f of dx is equal to f of b minus f of a. And what is application of integration actually? Integration is widely used in calculating areas and volumes, area under a curve, area volume of solid. We'll see some problems like that. Also solving differential equations, it's a special type of differential equation. We can solve this equation by use of integration. Physics problem, we know in physics problem we have to use integration. Calculating work done by force, finding centers of mass. And economics also, to determine consumer surplus we have to use integration. Now come to the problem. This is my first problem. We are given two functions, we have to evaluate this integral, second part this integral, and then we have to find the area region enclosed by these two curves, okay. First, part 1, root over gx, we substitute this to root over 2a minus x squared dx. We can write this by root 2 whole square minus x square. If we substitute x by root 2 sin theta, we get dx is equal to root 2 cos theta d theta. Then we get easily root 2 whole square minus x square. We substitute x by root 2 sin theta, and here we get root 2 cos theta instead of dx. Then we find here 2 minus 2 sin square theta, and here 2 cos theta, root 2 cos theta d theta. And then here x equal to root 2 sin theta, and sin theta is equal to x by root 2. So cos theta is equal to 1 by this is not part of my problem. I just show this to understand the line, this line easily. So we can get cos theta is equal to root over 1 minus x square by 2. So here we get a root over 2 times 1 minus sin square theta times root 2 cos theta d theta, and root 2 cos theta times root 2 cos theta d theta, root 2 cos 2 cos square theta d theta, which we get 1 plus cos twice theta d theta. And here the integration of d theta plus integration of cos twice theta d theta, then we get theta plus half sin twice theta plus c. And here we get a sin inverse x by root 2 instead of theta. Similarly we get x by root 2 instead of sin theta, and root over 1 minus x square by 2 instead of cos theta. This is my value, okay. Now second, in part b, we have to find this integration of 1 by fy gy. Then we substitute this by y square times 2 minus y square. We have to, I will use a partial differentiation here. I can write y square equal to x, then you can easily write it 1 by x times 2 minus x is equal to a by x plus b by 2 minus x, okay. B by 2 minus x. Then now we easily find 1 is equal to a times 2 minus x plus bx. When x is equal to, we get b is equal to 1 by 2, and x is equal to 0, we get a is equal to 1 by 2. So 1 by x times 2 minus x is equal to 1 by 2 times 1 by x minus 1 by 2 times 1 by x minus 2. So final answer is 1 by y square times 2 minus y square is dy is equal to minus 1 by 2y minus 1 by 4 root 2 ln y minus root 2 by y root 2. We have here I substitute x by y, y square, okay. And I find 1 by x in this line. I apply the integration as well as I substitute x by y square, okay. So then we easily I apply here the formula of integration, which is a to the power n, if x to the power n dx is equal to x to the power n plus 1 divided by n plus 1, okay. And here I apply this formula, root 1 by x square minus a square. So then we get 1 by twice a ln x minus a divided by x plus a plus c. These two formula I apply here. Now second, last problem. In last problem we are asked to find the area enclosed by these two curves. These two curves. Here I draw the curves. If I draw the curves, we get a figure. I get a figure like this. Here we have two curves, okay. Y equal to fx is equal to x square, and y equal to gx equal to 2 minus x square, okay. So point of intersection will be 1 plus 1 and minus 1 1. So area, the region enclosed by the curves, equation 1 and equation 2 will be 0 to 2 times 0 to root 2 y minus y1 minus y2 dx. Y1 is equal to 2 minus x square minus y2 x square, okay. And then I find here 2 times 0 to 1, 2 minus 2x square dx, and when I apply integration here I get 8 by 3 square units, okay. There is an alternative of the same problem. The area of the region enclosed by the curves 1 and 2 is OABCO, okay. 2 times OADO where x is equal to 0 to 1, 2 times ABDA where x equal to 1 to. Easily I can apply this formula, 2 times 0 to 1 x1 dy, 2 times 1 to 2 x2 dy. Here I substitute x1 by root over y dy. Similarly I substitute x2 by root over 2 minus y. Then I apply integration and got our answer 8 by 3 square unit, okay. Just I have to remember, we have to remember that we have to multiply this area by 2, okay. OADO again 2 times ABDA, okay. Now in this is actually a formula. I thought I should show this root over y square x square minus x square dx. If we substitute x by a sin theta, then we get dx equal to a cos theta d theta. So x square is equal to a square minus sin square theta. We get a cos theta times a cos theta d theta. A square by 2 to cos square theta. 2 cos square theta is equal to 1 plus cos twice theta. So here I apply, if I apply integration here, d theta a square by 2 cos twice theta, so I get a square by 4 sin twice theta. And similarly again we have to substitute theta by sin inverse theta equal to sin inverse x by a from here, okay. Then we get the formula. In mathematics, when we see these types of integration in a problem, we can easily use this formula, okay. Now next problem. here we have given two scenarios. We have to first evaluate this, then evaluate this integration, then we have to find the area of the smaller part which is bounded by the curve in scenario 1 and the straight line. Okay, so first integration is dx by a square plus 4x square. Here I apply x square plus 2x whole square. I can easily write 1 by a tan inverse twice x by a. Second integration of x times f of x. I substitute f of x by sin inverse x dx. Here I apply the UV formula or light formula. First I have to integrate this, then minus differentiate the second term as inverse term, then again integration x, and we have to integrate whole this term again. Okay, just apply simple here. I have to here the minus same sign, and again we got a x square here. Since we get x square here, we bring extra 1 minus x square minus 1, so this minus we bring this minus here. Okay, so it becomes plus, so half x square sin inverse x, half times root over 1 minus x square dx minus 1 by root over 1 minus x square dx. So we finally got our answer. This is our answer. Again we apply the same formula, this formula which I showed you before. Now in part C, we are given two equation. We have to find the area area enclosed by the equation circle and a straight line. APBA will be area of OA PBO, this whole area minus only this area APBA. Okay, this whole area from we have to subtract from this whole area this area, this triangle. Okay, so 0 to 2 y1 minus y2 dx, then I have to bring two part. You have to divide it into two parts, first part, second part, then again we apply the formula and we get our final result, which is 2 times pi by 2, which minus 2, and get pi minus 2. Okay, now last problem, we have to integrate root over 1 by root over 1 x square minus s square. I have to substitute x by a sin theta, then I get a cos theta d theta in the numerator, and in denominator root over a square minus a square sin square theta, and we get integration of the theta. We get theta here only and theta plus c, and we get sin inverse x by a. So this is our the problems I bring for today, and hope this problem will help you to get the concept of integration easily. And please suggest me which problems I can bring for you later, and subscribe my channel please, and support me, and all your support will motivate me to upload more videos for you. Thank you everyone. Assalamu alaikum.